Today's lesson is going to go over exponents and polynomials. A monomial is a constant, variable, or product of numbers and variables. Some examples of monomials could be just any number. So like -6, it could be positive, it could be 0, it could be any number. A number and a variable, so 7x, let's say. Or any combination as long as it is a product of numbers and variables. So we could have something like 1/2 x squared y. There are no addition or subtraction symbols in that. It is all a product of numbers and variables. We're going to talk about exponent rules next. So the product rule says that if we have x to the a power times x to the b power, we add those exponents. We get x to the a plus b power. So for the example column, if we were to give those numbers, so x cubed times x to the 7th would be x to the 10th power. The power rule is for when we raise an exponent to another exponent. So if we had x to the a power raised to the b power, that would be x to the ab power. So we multiply those exponents. With numbers, we could have something like y to the 6th squared, and that would give us y to the 12th. The quotient rule is for when we are dividing with exponents. So if we had x to the a over x to the b, that would be x to the a minus b. So it's always top minus bottom. If we had actual numbers with that, so b to the 5th over b cubed, that would give us b squared. If you struggle with memorizing these, another way to visualize this is b to the 5th is b times b times b times b times b. B to the 3rd is b times b times b. And so these can cancel because b divided by b is 1. And so if we cancel as many as possible, we're just left with b squared. So that's just another way to visualize that one if it gives you trouble. The negative exponent rule, this is gives you the reciprocal of something. So I want you to leave room to write a little extra in this box. If you just have a regular number that's not a fraction to begin with, so like if we have x to the negative a, then we would put this as 1 over x to the positive a now. However, if you start with a fraction, it's the same thing happening, but it looks a little different, and it's helpful to have seen it before. If we had x over y to the negative a, that would equal y over x to the positive a. So either way, you're still just doing the positive exponent to the reciprocal of the base. But I think it's helpful to see it both ways. So in the example column, let's do p to the negative 2. That would be 1 over p squared. And the counterpart to that could be, I don't know, p over 7 to the negative 2. And that would be 7 over p squared. Or it could be other variables where the 7 is anything. Okay. The zero exponent rule says that anything at all raised to the 0 power equals 1, with one exception. 0 to the 0 power is undefined. So we could have anything at all in parentheses, so like 4x cubed, and if we raise it to the 0 power, it still equals 1. We could have 2,347,000 blah, blah, blah to the 0 power, and it would still equal 1. When we are simplifying monomials, there are going to be a lot of different ways to approach them sometimes. So for example, in number 2, I could apply that -2 exponent to both of the things inside the parentheses, Or I could simplify the things inside the parentheses first. There are several ways to do it because at the end of the day, it's all multiplication. And so it makes the order of that really flexible for something that looks like number 2. What I'm going to choose to do at first is to flip this and make this a positive. So if I flip this over, I get 3 to the negative 1 over 5 to the 0 to the positive 2. Now, I know that 5 to the 0 power is 1, so that's just something simple that I can change really quickly. So 3 to the negative 1 over 1 squared. Now, I could deal with this negative 1 and it being inside of a fraction or whatever, except that this is over 1. So this is really just 3 to the negative 1 squared. Now, when we take a power to a power, we multiply those exponents, so we can get 3 to the negative 2. And anything to a negative exponent, we take the reciprocal, and then our exponent becomes positive. So we would get 1 over 3 squared, or 1 over 3 squared. Both are correct. Either way, we get 1/9. Okay, on number 4, we're going to start by simplifying the fraction. 57 over 3 actually just equals 19. And then x to the 4th over x, we subtract our exponents and get x cubed. And y to the negative 2 over y to the negative 3. Negative 2 minus negative 3 is positive 1. So we just get y minus 11x cubed y. Now, in order to add or subtract terms, they have to be like terms. So like terms have to have all the same variables with all the same exponents. Sorry, that's so sloppy. But all the same variables with all the same exponents in order for you to combine them. So we have x cubed y, x cubed y. These are like terms, so we can combine them. So 19 of these minus 11 of these is 8 of those. So 8x cubed y would be your final answer. All right, for number 6, we're just going to simplify a piece at a time. So when we look at our coefficients, so first of all, we have this negative. It's not going anywhere. 18 over 42 reduces to 3/7. And I usually like to work with stuff with as little fractions as possible. So I'm going to keep the 3/7 as a coefficient at first. So a to the 8th over a to the 5th would give us a to the 3rd. And then b to the 4th over b to the 7th would give us b to the negative 3rd. Now, when we write our final answer, anything with a positive exponent goes in the top of a fraction. Anything with a negative exponent goes in the bottom of a fraction. So our negative is still in the front, and we get 3a cubed over 7b cubed. And once we put our negative exponent in the bottom of the fraction, it turns positive, and our final answer is completely simplified. On number 8, I'm going to begin by applying the exponents on the outside of the parentheses. Now, I tend to refer to this as distributing exponents, but it's very important that you understand that that's not something you can do if there's addition and subtraction. Because if we have x plus 7 squared, you cannot say x squared plus 7 squared. You have to FOIL this binomial. You have to do x plus 7 times x plus 7 and distribute both terms, and you get 4 terms back. It's a whole process. However, when it's monomials, so it's all multiplication inside of here, we can apply that exponent to each individual piece, kind of like distribution. So 1/2 to the 3rd power would be 1/8. M to the negative 2 raised to the 3rd is m to the negative 6. N cubed would be n to the 9th times 1/8 to the negative 2 if you remember, we flip this and then the exponent becomes positive. So that would be 8 squared. We would get 64. And you can put 8 squared here if you'd like to help you. M to the negative 1 raised to the negative 2 would be m to the positive 2 power. And then n to the 4th raised to the negative 2 would be n to the negative 8th. All right, now I'm going to work on multiplying these two monomials together. 1/8 times 64 is 8. M to the negative 6 times m to the 2nd would be m to the negative 4th. N to the 9th times n to the negative 8 would be n to the 1st, because 9 minus 8 is 1. So now to write our final answer, anything with a negative exponent needs to go into a denominator. So 8 and n both have positive exponents of just positive 1, so they stay on top. And then m to the 4th will go on the bottom. And that's our final answer. Polynomials are the sum or difference of many monomials. And the highest exponent of a polynomial is called the degree. This is going to be important. Standard form is when we write those exponents in descending order. Now we're going to talk about classifying polynomials. And when we classify polynomials, we give them a first name and a last name. So their first name comes from their degree, which we said was the highest exponent in that polynomial. Their last name comes from the number of terms. Okay, and terms are separated by addition and subtraction. Okay, now keep in mind, as we are classifying these, they are not equations, they are expressions, okay? So we are classifying things as without an equal sign. So if it is a constant, then that means that it is just a number. There are no variables at all. It is a constant value. If it is linear, that means it has a degree of 1, meaning the highest exponent is 1, so it could be something like x, or it could be something like 5x. There's multiple other things it could be, obviously, but those are simple examples. Quadratic, think about a quadratic function. X squared would be quadratic. Anything where the highest degree is 2 is quadratic, or highest exponent is 2 is quadratic. Cubic is when the highest exponent is 3. Quartic is when the highest exponent is 4. So think 4 quarts in a gallon, 4 quarters in a dollar, 4 quarters in a football game. 5 is quintic. I typically compare this to quintuplets, which is, crazy, but still, that's the only quint thing that I think about that is very common. The last name on the polynomials is more common. I think that these are common terms that you guys are used to. So one term is a monomial. That's what we've been talking about in this lesson so far. A binomial is 2 terms. So x plus 7 would be a binomial. There are a lot of other examples, but that's a simple one. A trinomial would be 3 terms, and anything with 4 or more terms is a polynomial. When we add and subtract polynomials, our goal is to combine like terms. So in this case, we are doing a subtraction problem. We need to keep in mind that that subtraction applies to everything in the second polynomial. So the easiest way to do that is to just distribute as if that is a -1 in front of the parenthesis. So if we were to put a coefficient here, it would be a 1 on the first polynomial. That is a +1. That will not change anything when we distribute, but our parentheses will be gone. If we put a 1 here, that is a -1 that we are distributing. So it will flip every sign in the second polynomial and get rid of our parentheses. So the first polynomial stays the same, 3w squared plus 2w minus 6. And the second polynomial changes every sign. Minus 9 minus 3w squared minus 7w. So now a little trick that I like to use, you don't have to do this, it doesn't matter to me, but whenever you get a lot of terms like this, I will go through and underline the term with however high the exponent is. So like I have w squared, so it gets 2 lines. W gets 1, constants get a squiggle. And this is just my method to help keep myself organized. So I know that standard form has the highest exponent first. So I always start with that one, and that way it's just already in standard form, and I don't have to worry about an extra step. So we have 3w squared minus 3w squared. So those are actually just going to cancel because that would be 0. Then we're going to do the w's, 2w minus 7w. That is negative 5w. And then negative 6 minus 9 is negative 15. Now you'll notice in our instructions, it also asks us to classify our solutions. So the degree of this expression of this polynomial is 1 because that's the highest exponent. So this is a linear binomial because there are 2 terms, 1, 2. So a linear binomial is the classification for this one. Okay, now we need to multiply 3 binomials together. This is ugly, but it's not difficult. It's just a little bit tedious and detail-oriented. So we can only multiply 2 things together at a time. So we're going to multiply the first 2 together. You could pick any 2, but it just makes the most sense to me to start at the beginning. So we will distribute 2v to both of those and then distribute 3 to both of those. And whatever we get, we still need to keep it in parentheses because it then needs to be multiplied by the final binomial. So 2v times 2v is 4v squared. 2v times negative 3 is negative 6v. 3 times 2v is positive 6v, and 3 times negative 3 is negative 9. Now I notice that my middle terms cancel in this case. And so now our next step will be 4v squared minus 9 times negative 3v plus 1. And we'll repeat the same process we just did because once again we're multiplying binomials. So distribute the first term, then distribute the second term. 4v squared times negative 3v is negative 12v cubed. 4v squared times 1 is 4v squared. Negative 9 times negative 3v is positive 27v, and negative 9 times 1 is negative 9. Now I notice there are no like terms, and my exponents are descending, so that means that we are in standard form. So this is my final polynomial, however, I need to classify it. So the highest degree, the highest exponent is 3, so this is cubic. And there are 1, 2, 3, 4 terms. So this is a cubic polynomial. Now I chose to do number 17 as an example just to show you another technique I use when multiplying trinomials. So with trinomial times a trinomial, we have to distribute all 3 terms in the first one to all 3 terms in the second one. So we're going here, here, and then again with the negative 6 to everything. So that is a lot, and it does get messy. It works out kind of nicely if we give each distribution its own line in our work. So p squared is what I'm going to distribute first. P squared times p squared is p to the 4th. P squared times negative 2p is negative 2p cubed. And p squared times 1 is positive p squared. So I distributed that one. Now I'm going to distribute p. P times p squared is p cubed. Instead of writing that out here, I'm going to write it under the other p cubed. And since it's positive, I'm going to put plus. So plus p cubed. Then p times negative 2p is negative 2p squared, conveniently located under the other p squared. And then p times 1 is positive p. So that one is now distributed. So now I'll distribute the negative 6. Negative 6 times p squared would be negative 6p squared. So I'll put that under the other p squared terms. Negative 6 times negative 2p is positive 12p. And negative 6 times 1 is negative 6. Now, if you look at this, when I combine like terms, they're already organized in a way that I can just add the columns. So I'm going to get p to the 4th minus p cubed minus 7p squared plus 13p minus 6. And that is my final simplified polynomial. This is a quartic polynomial. And that is all for today's lesson. Thank you.